Hi everybody, in this video let's look at few more examples for this sine rules. 2 point M and N, so we have 2 points over here, M and N. On the horizontal ground near one of the Petronas twin towers are identified. The points are 300 meters apart and form a straight line with the towers. So the distance between point N and point M is 300 meters. Okay, the angle of elevations of K from point M is 44 degrees 30 minutes, and the angle of elevations of K from point N is 70 degrees. Calculate the height of the towers correct to the nearest meters. So we are looking for the height of the twin tower. Okay, let me draw a diagram for you first. Okay, let's use this diagram to help us to solve this question. So this is 90 degrees. So this is point K, and here is point M, and this is point N. The distance here is 300 meters. Okay, can you see it? Okay, the distance here is 300 meters, and this angle is 44 degrees 13 minutes, and this angle is 70 degrees. Okay, so now let's focus on this triangle first. If now I'm looking for the height, which is here. Okay, now let's focus on this triangle. I know that if I can find the length here or here, I can actually use trigonometry to help me to get the height, right? Okay, for example, let's say if I can get the height of this the length of this Kn, I can use sine. So I hope that you still remember this. Do, ka, so. Tangent is equal to opposite side divided by the adjacent side. Cosine is equal to adjacent side divided by the hypotenuse, and sine is equal to opposite side divided by the hypotenuse. So if I can get the length of Kn, sine 70 degrees is equal to S O opposite H hypotenuse. So it's equal to the height divided by Kn, right? So let's say if I'm able to get the length of Kn, I just bring the Kn over here, take the length of Kn times sine 70 degrees. So I will be able to get the height, right? Okay, so now I need to find out how do I get the length of Kn first. Okay, let's focus on this triangle now. So now we forget about the H first, forget about the height first. We try to think, how do we get Kn? Okay, so Kn, I can use sine rules actually to help me to get the length of Kn, right? If this is 70 degrees, you know that here must be 110 degrees, right? Because a straight line, a straight angle will be 180 degrees. You take 180 degrees minus 70 degrees, then you will be able to get 110 degrees. Okay, so we also know that the sum of the interior angle of a triangle will be always equal to 180 degrees. It means that this angle plus this angle plus this angle, we know that it must be equal to 180 degrees. So if I want to get this angle, it will be very easy, right? MKN is equal to 180 degrees minus 110 degrees minus 44 degrees 13 minutes. Okay, just use our calculator to help us to get the answer. Okay, it is 25 degrees 47 minutes. Okay, let me label it first. 25 degrees 47 minutes. Okay, so now I want to find Kn, right? I put Kn on the top. Kn over sine 44 degrees 30 minutes is equal to Mn, which is 300, over sine 25 degrees 47 minutes. Okay, then I will be able to get the Kn easily, right? Take 300 divided by sine 25 degree 47 minutes time sine 44 degree 13 minutes. Okay, 300 divided by sine 25 degree 47 minutes time sine. Okay, it's equal to 480.98 meters. Let me label it first. So here will be 480.98 meters. Okay, the length here. Now, if I have, now I got the length of Kn, right? So I can get the height easily. So let me plug in this whole thing into here. So sine 70 degree is equal to height. Now I'm looking for the height of the Petronas Twin Tower over Kn. Kn is equal to 480.98. Okay, so height will be equal to 480.98 times sine 70 degree. Okay, so 480.98 times sine 70 degree. You will get 451.97 and something, right? Very long decimal. And the question asks us to correct to the nearest meter. So it will be 452 meters. So this is nearest meters. Okay, so this is the answer for this questions. Let's look at one more questions. The above diagram shows a triangle ABC. This is an obtuse angle triangle because this is an obtuse angle, the angle more than 90 degrees. Calculate the obtuse angle of ABC. Okay, so we are looking for this angle. We can use sine rules, right? Sine, I want to find angle, I'm going to put the angle on the top. Sine angle ABC over 12 is equal to sine 35 degree over 8. Sine 35 degree over 8. Until here, you have to be more careful. Later on, when you press your calculator, right, the answer, the calculator will give you an acute angle. Okay, let me show you here. So if you want to straight away get the answer, you can actually get press this way, sine 35 degree 35. Okay, you don't have to press the degrees, okay, because calculator now is set in degree, so it know that you are keying in angle in degree. So over 8. Okay, then times 12. Because I moved the 12 over here. Okay, then shift sine answer. Okay, so this is the angle, but the question is asking obtuse angle, right? So we know this is not the answer. If I want to get the obtuse angle, I need to take 180 minus the answer that I got just now. So this is the answer that we want for this questions. So if you don't want to do this way, you can actually do it this way. Sine angle ABC is equal to sine 35 degree over 8 times 12. Okay, you can press this one first. Sine 35, sine 35, okay, over 8 times 12, right? Okay, so you can take 5 decimal places if you want to be more accurate, or you can just take 4 decimal places. How about I take 5 decimal places? 0.86036. Oh, sorry, 0.86036. Okay, 0.86036. 0.86036. Okay, so this is equal to sine ABC, angle ABC. So if I want to get angle ABC, 0. Okay, I have to press the shift first, shift. then sine, okay, 0.86036. Okay, so this is not the answer that we want. As I told you just now, this is an acute angle. The question is asking obtuse angle, so we have to take 180 minus the answer. So you get 120.64. 120.64 degree. Okay, so this is the answer for this first part. Let me label first 120.64 degree. Okay, let's proceed to the second part. Sketch and label a triangle that is different from triangle ABC in the above diagram such that the length AC is still the same and the length BC is still the same and the triangle BAC and the angle BAC are maintained. So we can actually draw another triangle which has all this information given here: 35 degree, 12 centimeters and 8 centimeters. So this is ambiguous case. How do we draw another triangle? Let me use this triangle to show you. So I can actually extend this line. So the another triangle will be actually here. So this is 8 centimeter, right? So you can go over here. Okay, so this is actually another triangle that we can draw. Okay, let me erase this one first. Okay, erase this one, the one that's... So this is 8 centimeter, here also 8 centimeters, and this is, let me label it another B2. Okay, this is B1, this is B2. So this is ambiguous case. Okay, so sketch and label the triangle that's different. We want to sketch, so what you need to do is just draw the triangle A, C, and B2 and label the length 8 centimeter, 12 centimeter, and 35 degree. Okay, let's look at part C. Based on the triangle you sketch in B, which is this one, state the acute angle of ACB. ACB. So we are looking for this angle. Oops, sorry, I typed wrongly. Not ACB, but should be ABC. Okay, ABC. Should be ABC. So the first part, we calculate the obtuse angle of ABC. We got 120.64, which is over here. 120.64 degree. Okay, in the previous video I told you that these two angles actually they have a relationship, right? They plus together will be equal to 180 degree because this angle is actually equal to this angle, correct? Because here we have an isosceles triangle. And we know this angle plus this angle definitely will be equal to 180 degree. So if you want to get the acute angle of ABC, then it will be very easy. Okay, which is here. What we need to do is just take 180 degree minus 120.64 degree. Okay, 180 minus 120.64. 59.36 degree. 59.36 degree. Okay, correct. Let's go to the last part. If the length of BC is shortened while the length of, okay, now the BC becomes shorter and shorter. Okay, we want to shorten this length of BC, and the BAC we cannot change, we don't want to change this angle. BAC are maintained. Find the length of BC such that only one ABC is formed. So now with this length we can form two triangle ABC. Now the questions want us to find the length of BC. We want to shorten this length so that we can only form one triangle. So we know that here, okay, let me use another color. Okay, let me use this color. If I make it become very long here, if the green line here is longer than trough, they can actually form one triangle only, but it become longer. The question is asking shortened. We want it become shorter than the BC. Oh, so how do we find the length? So we know that it will be actually over here. From here, it becomes shorter, shorter, shorter. Okay, until here. Until here, there will be only one triangle can be formed, A, B, C. So this is a length. This is a length that we are actually searching for. When the BC is equal to the height of this triangle, there is only one triangle can be formed. Okay, now we are going to find the length here. So how do we find the length here? You try to think. We can actually use sine, right? So this is 90 degrees. Sine, okay, this is part D. Sine 35 degrees is equal to S O height H, SOH, which is trough. Okay, so the height is equal to trough times sine 35 degrees. Trough times sine 35. Okay, 6.8829. This is centimeters. Okay, so the length of BC will be equal to 6.8829 centimeters. When the BC is equal to 6.8829 centimeters, there's only one triangle we can form, which is this one. Okay, for this video I stop here first. See you next time. Thanks for watching. Bye bye.